All right, so we're in Algebra 2. Today's lesson is 9-10, constructing sinusoidal functions. We're going backwards. Today's date is Wednesday, March 4th, 2020. I already see a hand that wants to read the objective, but only one that has a card in it. Brian.
So using 2 points from midline or stream, write the equation of the sine and cosine functions.
There it is. You said you didn't have the notes, Jane? Okay. I will print this out for you with my printer. I don't know why we're so short on notes. I don't know what happened there. Print out to... Yes.
I already did this, but Titi told me that you guys did another.
That's what it is. Okay, so it's every single person that went to softball took some of the notes already, and that's why I was short. Okay. Is there anyone else that doesn't have the notes? It's just Jaden and Leo? We finally solved the mystery. Here you go, Jaden. All right, so our general formula, once again, there it is. What does each of these letters, what do each of these letters do to our function? What is A with a quiet raised hand? Emily. A is the amplitude. Write it down. And we're going to connect that to the graph in just a sec. For now, I'm just purely doing the analysis of our equation. What about B? What does B do? Caroline? And I like how you said it isn't the period, it affects the period. Well said. I know that you're getting tired. This is probably like the 4th time that we've written this stuff down. Hopefully you're memorizing it now, though, from writing it down so much. And what is the formula for a period? If we have B and I want to find what period is, I'm assuming capital P is period. Chewy, what do I do?
It's 2 pi over b.
2 pi over b. Thank you. Ooh, I'll try a hard question, see if you guys can get it, because I haven't taught this yet. I briefly mentioned it last lesson. What is H? We don't know it. You guys know H? Sam, yeah.
Well, like, isn't it like horizontal something?
Horizontal, yeah. What's that move that means move, or the more formal word? Do you remember what it means? India?
Phase shift.
It's phase shift or horizontal shift. Exactly, yeah. Both of you, I'll take your cards. Yeah, and again, as a reminder, please turn in your cards. You can either pass it around or walk it in like Chewy just did. Thank you. So H, I'm going to write it in a different color because we haven't learned it yet. I've mentioned it. This is the phase shift, which is a fancy sounding name, and I like Sam's description of it better in terms of the layman's term, and I like how formal you were about it as well, India. Phase shift is how much we're moving our function left and right. We will learn that tomorrow. K. What is K with the quiet raised hand? Leo.
Midline.
It is indeed the midline. Thank you, Leo. And thank you for turning in your card immediately. That is our midline. All right, so I want to connect everything that we see right here in our equation to the graph. What is A doing to the graph? What is B doing to the graph? What is K doing to the graph? All right, so first of all, where's A? In terms of this graph, where I don't see any A. You said it's the amplitude. Where is the amplitude then? See 1 hand, 2 hands, 3 hands. See one of them with a card, giving you time to think. Yes, Oscar.
Would be the first dot.
The first dot right here?
Yeah.
Not quite. So amplitude is how wide the function is. This dot doesn't tell me anything about how big the function is. So what point would it be?
Would it be the one with the line?
This one here? Or?
Yeah.
Yeah, it is, yeah. And in fact, it's the distance, the y coordinate of that point from the midline. So let's all label that in our notes. Thank you, Oscar. I'll take your card. This is the amplitude. It's one of those things, if I could write sideways on my stylus or with my writing pad, I would do it. It is the amplitude. It isn't exactly equal to A. Does anyone remember why it's not exactly equal to A? And I'll give you this. Sometimes A is negative. A is -2. Our amplitude is always positive. I'm talking just purely about amplitude. So amplitude is the absolute value of A, and there it is. So it's how wide our function is in terms of our extreme. What about K? What does K affect in terms of this graph? I see 1 hand, 2 hands, 3 hands, 4 hands. Do any of those have cards? Oh yeah, Loretta.
Is it the orange line?
It is the orange line, yeah. That is the midline. Let's all label it. This is the midline. I'll ask you something that I haven't really written down, but the difference between sine and cosine. Let's assume we can move our y-axis to choose wherever we want. So between this point and this point, if this was the start or if this was the start, which one would be sine and which one would be cosine? Lots of hands. Still a few people that need to get in. Look back at your notes for 9-9, or I think it's just 9-9, yeah. Look back at your notes for 9-9. If you don't know this, I'm going to cold call if I don't see someone with their card. Look back at your notes for 9-9. Yeah, Jaden. You choose either point. Dealer's choice.
The midline?
So this midline one, is that going to be sine or cosine?
Cosine?
Ooh, it was the other one.
Sine.
Sine, yeah. Sine always starts at the origin. Sine always starts with the y-coordinate of 0. So that is the sine of x starts here. Sine of x starts here. And therefore, Jaden, this other point must be,
Cosine.
yeah, cosine of x starts here. Thank you.
Wait, so it starts at 0, 0?
So sine starts at the origin, 0, 0, and this isn't the best way of explaining it because technically I'm moving the graph now in order to make them on the y-axis. There is no y-axis, so if I assume the y-axis here, now it's a graph of sine. If I move the y-axis here, now it's a graph of cosine. Question, Larry?
Is the cosine just a part of sine?
Yeah, it is, and you can actually make a sine into a cosine or vice versa, a cosine into a sine if I phase shift it, if I move it left and right.
So you just like cut off part of the sine wave to make
Yeah. All right, and the last thing that I want to talk about is how much of a period do we have? So I'm going to do, everyone's going to hold up. How am I going to do this? I'm just going to say, I'm going to call in a quiet raised hand. How much of a period is this? Is this a full period? Is that a half period? Is it a quarter period? From here to here, how much of a period is that? Sam?
Is it a full period?
It is a full period, thank you. What about from here to here? How much of a period is that? From a extrema to another extrema, from a maximum to a minimum, how much of a period is that? Cheyenne, yeah. It is half period. What about this amount of a period right here? How much is that? Leo? Quarter. All right, cool. There's our review. Seems like we're doing really good. Thank you. So let's move on to the new stuff, the hard stuff. We have example number 1. So it's a sinusoidal function, so it's either a sine or a cosine wave. It's intersecting its midline at 0, 5, and it has a maximum at 2 pi, 9. That's all we're given. Given 2 points, and knowing it's a sine and a cosine wave. It feels like we're lacking a lot of information. It does tell you that we want to enter our function in radians also. So that means that we're doing 2 pi divided by the period instead of 360 degrees divided by the period, just like we're used to. So no changes there. All right, so let's go ahead and try to do a sketch of this. What's happening? And your sketch is a sketch. It does not need to be 100% accurate. You can modify it at will. So midline at 0, 5 and a maximum at 2 pi, 9. So off to the left here, let's make our sketch. So let's graph 0, 5. Roughly, and again, it's just a sketch. 0, 5 means 0 in the x-coordinate. I'm not moving left or right, and I just go straight up 5. We should have that point. And if you want, you can label it, that's 0, 5. You don't have to, it's just meant to try to determine if this is a cosine or a sine wave. And then finally, I have a point 2 pi, 9 somewhere else. So notice that 9 is bigger than 5. 9 is the y-coordinate, so we should have a point that is now above this point somewhere out here to the right. And it's just some arbitrary distance, I haven't labeled it, so I'm going to say right there, that's 2 pi. And I should have a point that's slightly higher. A point that's slightly higher, sure, right there. Let's call that 2 pi, 9. 9. So you have 2 options for a graph, and depending on how well you read the problem, it can be one of these 2 options. I'm going to draw both of those options. You are just going to not draw anything and try to figure out which one of them it is. So I could have a function that looks like this. This could either be a minimum or it could be a midline. So I could have something that looks like that, where that's the minimum. Or, on the other hand, I could have something it's not gonna see that looks like this, where this is the midline, and I come up through this point, and that's the maximum, and I come back down this way. I will repeat that once again. This first point could be a minimum, or it could be a midline that I go through in order to get to a maximum, which means this point could be either a maximum, or I could make it into, or this would be the midline, because it goes through this point up here. So this is either a midline or a max. This is either a minimum or a midline. Which graph do I have? Do I have the orange graph or the green graph? Does there require his hand that can explain their answer, not only just answer it? India?
The green graph,
Why?
because in the problem it says the midline's 0 to 5.
This is a midline. That means I go through it. It is the green graph. So everyone now copy down the green graph. Hopefully you draw it a little bit neater than Mr. Sindel. This has to be a midpoint. So it has to come up, and I'll do this in a slightly different color. It comes up through here, and that is a maximum right there, and then it comes back down. All right, so on my y-axis, I started at the midline. You can even write start. We started at the midline. Start at midline. All I'm doing right here, again, is trying to build you your parent function. Is your parent function going to be sine or cosine if we are starting at the midline? Go back up. We just did this. If we're starting at the midline, are we sine or are we cosine? Sam? Sine. All right, so let's start off our function with Sam's parent function. It's sine. We know that we have sine of x. Everyone copy it down. Our parent function is sine of x. I guess you can even just leave it sine of something because we don't know what goes in there yet, but sine of x is fine. That is our parent function, sine of x. All right, now we have to figure out what our amplitude is. Again, we're kind of going all off of our sketch here. How far do we move between our midline and our maximum? What is that distance here? Is there any way that we can figure out how far we traveled to get from our midline height to our maximum height? I see one hand, two hands, three hands. Anna?
Subtract the x-axis and divide by 2. No, yeah, just subtract them.
Subtract the 2 pi and 0?
No, the 9 and the 5.
Oh yeah, the 9 and the 5?
Yeah.
Yeah, so those are the heights, and you have it correct. So if we just subtract the heights, that means it's the difference in the heights. That's literally what it means to be a difference. 9 minus 5. This distance here is 9 minus 5. This distance is 4. Again, amplitude is all about how much we're changing in our heights. We started at 5, and then we went up to 9. From 5 to 9, that is adding 4. Our amplitude is 4. So we can say amplitude is 4, and that means A is equal to 4. The only thing that will cause A to be a negative value is if instead of starting up, I start going down. Down means negative, positive, that's going up. We went up, therefore we have a positive value for A. And I'm going to write that down in the notes just in case you didn't catch it. A is positive if going up, if starting up. I can't spell. Starting up. And finally, A is negative if starting to go down. All right, and I know that this is typically about the hardest part that we're going to do now, the period. We're all scared of the period because it requires a formula. We have to figure out the period just from our sketch, just from this word problem. So first of all, can someone tell me what my formula is for period? Once again, what is our formula, Caroline?
2 pi.
2 pi over b. The period is actually equal to 2 pi over b. And we actually can figure out what the period is if we're really crafty. So remember at the very beginning when I asked you how much of the period is it from here to here, or here to here, or here to here? That's what I'm doing now for these 2 points. I can't see the entire function, so it's harder. But I know I'm going from the midline to the maximum. I know that I'm going from the midline to the maximum. I'm doing that amount of the period. How much of the period am I really doing? I only have 2 hands. I need more hands. You guys were doing really well in the period up above. How much is this? From the midline to the maximum. From the midline to the maximum, that is the, what, Sam? Quarter. Yeah. We have a quarter of the period. So we'll make a note that we have 1/4 of the period. So we can come over here to the left and we say we have 1/4 of the period is equal to 2 pi times b. But we also know how far we've traveled in that quarter of a period. How much in the x direction have we traveled between this point and this point? What is this distance right there? How can we find that? India?
Since it starts on the, it starts at 0 for the x-axis, and you go to 2 pi, it's 2 pi distance.
Yeah, there it is. 2 pi distance. 2 pi minus 0 is 2 pi. This distance is 2 pi. So we don't even know what this formula is. We can even cross it off. We did not end up using it, but we know that a quarter of the period is, as India said, 2 pi. So there's 2 paths that I can take you on right now. There's the path where you can just kind of see the answer by using the formula, and there's the path that I just use logic. I'm going to go with the logic path first, which eventually does use the formula, but it's kind of I will show you this method, and you just use it as a hammer. It'll work every single time. Just hit the formula, or hit the formula hammer with the, I don't know what I'm trying to say. Just do this process over and over, and you'll get it. We know that 1/4 of the period is 2 pi. Therefore, the entire period is what? I'm going to rewrite this line once again to make it a little bit easier to see. 1/4 of the period is equal to 2 pi. 1/4 of the period is equal to 2 pi. How do we find how much the period actually is then? Lorraine?
Is it always that 1/4 is 2 pi?
So it's only 1/4 in this case because we were dealing with a quarter of the period. Sometimes this number will be a half. Sometimes that number will be 1. It really depends on what information is given. The information that was given to us was what is the distance between, or what amount of the period do I have between the midline and the maximum? And I went back up to my graph and I said, hey, midline to maximum is a quarter of the period. That's why I wrote 1/4. 1/4 is 1/4. And where did the 2 pi come from? The 2 pi is always just this distance, your delta x, your change in x. So right now I have 1/4 of the period is 2 pi, therefore the entire period is what? Only one person knows how to do this. If I just gave you this equation right here in Algebra 1, what would you have done to both sides to solve for p? We're trying to solve for the period. Leo? Not quite. 1/4 right now is being multiplied by p, so inverse operation of multiply by 1/4 is... All right, he gives it to you, Sam.
Is it divide?
Divide by what?
4?
Not quite.
Or wait, multiply?
Multiply by...
4.
Yeah, multiply by 4 will also get rid of it. Perfect. So we're going to multiply both sides by 4. Sam sees that it's going to cross-cancel these 4s. I'm left with a period is equal to 8 pi. I know it repeats every 8 pi. And hey, I have a formula that gives me a period now. Now I'm going to finally use the formula. So I'm rewriting this 2 pi divided by b, which is the entire period, which we now found. The entire period is 8 pi. Well, the entire period is also 2 pi divided by b. So now we have another equation to solve. We're trying to solve for this b. Who can help us? I have 8 pi is equal to 2 pi over b. Our equation right here. Someone help us solve. Yeah, Lorraine.
You could change it with it. Like you put 8 over 1 and change it to a 1.
Not quite, but having this divided by 1 does help us. When I have a fraction equal to a fraction, there's a certain process that I do. Do you remember what that was?
Oh, wait, denominator is the same?
That's when we add fractions. Do you remember what this thing is called when we go like that?
Oh, cross cancel.
Not cross cancel, but cross
Oh, cross multiply.
cross multiply. There it is. Yeah, thank you. I need a quiet raised hand to help me cross multiply. Who still has their card? Ooh, Aurelio, yes. Help me cross multiply, please.
8 pi times b.
8
pi b.
pi b, perfect. And then cross multiply the other direction, please.
And it'd just be 2 pi.
Is equal to 2 pi. Beautiful, thank you. And now we're going to solve for b. I need to now isolate b. Right now b is being multiplied by 8 pi. I need to undo multiply by 8 pi. What am I going to do to both sides of my equation to solve for b? 2 hands, I see 3 hands, 4 hands. Oscar, yeah.
By
By?
2 pi.
Ooh, careful. So I want to divide by whatever's
By
in,
b.
not by b, the coefficient of b. Whatever's in front of b.
So would it be 8 pi?
Yeah, by 8 pi. And I'm not done with you yet, Oscar. What happens when I divide both sides by 8 pi? I want to make sure you know what's going on here.
Well, 8 pi gets cancelled out.
Beautiful. And then what's left on the left-hand side?
B equals 2 pi over 8 pi.
There it is, 2 pi over 8 pi. Thank you. Yeah, so we've canceled it out. And one additional step, we're going to simplify this 2 pi divided by 8 pi. Is there another quiet raised hand that can do that for me? Yeah, Sam.
Is it just 2 pi? Because wouldn't you simplify the 4 pi?
What do you mean by that? You simplified the 4 pi?
Oh wait, never mind.
Okay. Is there anyone else that can simplify this for us? Sam, you can call on whoever is raising their hand right now. You can look around.
I'll give it to you.
Okay.
The pi's cancel out,
Pi's are gone.
and 2 and 8 can both be divided by 2, and that gets 1/4.
1/4. There it is. Thank you. Whew, that was hairy. I know, it was hard. Whew. That was the hardest part. We're on to the easiest part now, which is finding the midline. The period b is equal to 1/4. We know a is equal to 4. We know our parent function. The only thing left in our original function all the way up, where did it go? Up here is our k, our midline. So k on the midline, it will always be whatever your y-intercept is. Your y-intercept is always going to be your value of k until we talk about phase shift. So I'm kind of half lying to you. So midline, can you please write in your notes y-coordinate of the y-intercept? And if you want to simplify that and be a little bit informal unformal about it, you could just say it's the y-intercept, because most people say y-intercept is 3. It's really 0, 3, but yeah, the y-intercept. So what was the y-intercept in this case? I can jump back up to my graph. What was our y-intercept? Cheyenne? 5. K is 5. Done. Take a bow. You've completed all of the pieces. We just need to put them all together and we have our formula. So come down in here, write down Cheyenne's. K is equal to 5. All right, build it piece by piece, brick by brick. The first brick is A, and I'm going to write that down. A is 4. So I write down 4. What was our parent function? Our parent function was sine. Okay, what's going to go inside here? This is going to be the b that affects the period. So b we wrote over here. Maybe I should box all of my variables so I can actually find them. So I have b is equal to 1/4, so 1/4 of x, and then finally plus k plus 5, and box it. Whew, that was a bit of work, and it is going backwards. but there it is. You have created a formula from purely 2 points. And I will say one final thing before I let you try example 2 with a group. There are definitely more than one answers. There's an infinite number of answers. I could have done this with cosine, as kind of Lorea was pointing out earlier. It would have been harder because I probably would have had a phase shift. I could have done this with sine with different values also. Although I think that might have to still have phase shift. Generally speaking, there's probably going to be one easiest answer though, and it will look kind of like that. Okay, you guys need to ask me questions because you're about to go off by yourself into the mathematical wilderness here. Any questions before you move on to example 2 where you try it on your own or with groups? So Loretta and Jaden?
So, how do you know if it's a sine or cosine?
Yeah, great question. How do you know if it's sine or cosine? I'm going to give that to someone else. How do you know if it's sine or cosine? After we made the sketch and we compared it to up here, how do you know? Yeah, Sam.
It's sine because it starts in the midline.
There it is, yeah. Sine will start at the midline. Cosine will start at the minimum or start at the maximum. Or minimum or maximum. Question on top of that before we get to Jaden? Yeah.
No, that was my.
Oh, that was yours? Oh, perfect.
It's just, I don't know.
And that's how it works. One person asks a question because
That diagram down there.
others think about the same question. Yeah.
So, how do you know which, like, where the midline is if there's no graph?
If there's no graph, you have to make a sketch. 100% of the time, I highly recommend making a sketch because with our sketch, we can see that it crosses the Y-intercept here. It will always give you a Y-intercept.
So the midline is just where it crosses.
Yeah, where it crosses the Y-axis.
Okay.
There's 5 in this case. Yeah, good questions, good questions. Keep them coming. All right, I'm going to be circulating in the classroom, helping you with example number 2. Oh, question before we begin?
I'll just when you're done.
Okay, cool. We are working on example number 2. After you check with either me or a neighbor, hopefully a neighbor, and you get the same answer, you may move on to the homework on Khan Academy.